So here I've got a stack of Audiolab 8000A amplifiers. These are very well regarded amplifiers, and of course these have all got issues. The one on the bottom doesn't power at all, just bursts the fuse. And then you can see that we've got some missing. We've got a missing power button in the top one, and missing speaker button on the middle one. And then apparently the board in this one is all burnt. Although it does power, so we'll see what's going on with there. And then if we look on the back, classic problem with these amps is that all the input phonos, the plastic goes kind of brittle and then they just break off, so we'll need to kind of look at replacing these. So we'll work through these one at a time, and maybe one of them will become a donor, and we'll see what we just need to do. So we'll start with the bottom one. That doesn't power at all, and we'll see what we've got to find in there. So these units are all from the same owner. This is the bottom unit here. That's actually the cleanest unit, probably the oldest unit, with a grey finish on it. In very good condition. But this one was just blowing the mains fuse whenever you try to power up. And that could mean that we've got a faulty transformer, or either that or the load in the transformer is such that it's just popping the fuse. That could mean our output transistors are gone, or there's something in the output stage that's not quite right. But I've done a quick check on these transistors and they seem okay. But what I found quite quickly is, if we look at just the DC rails here, so here's our big reservoirs obviously, and the rectifiers under there. And if I measure on this is the negative rail, yeah, so we've got a sort of rising resistance here as the capacitor charges up, so that's all fine. If I look at the positive side, I've got 0.3 ohms, so there's either something wrong with the rectifier, the capacitor, or the circuitry beyond here. So the simplest thing for us to do right now is we'll just disconnect, and it's quite easy to do in these amplifiers. We'll just disconnect the rails from the board just by desoldering these wires here, and we'll see what side is this 0.3 ohms on. So right, so we disconnected that, and what we find is that the amplifier side is okay. Reading some high resistance there, so that looks healthy enough, which is good because that means we're not looking to replace transistors or any of the kind of circuitry. And of course these transistors are getting kind of hard to come by now. And so I've also disconnected the connection from the bridge to the capacitor, and what we find then is that the capacitor reads okay. And when we connect to the output of the bridge, we're reading a short. So either the bridge is gone or the transformer's got a shorted winding somewhere. So I think what we have to do now is turn the unit upside down, and we'll get access to the underside of the PCB, and we'll desolder the secondaries of this transformer and see what that tells us. Here we are on the underside then, and we can see these four big joints that are in a row there. That's our bridge rectifier, and then these other 2 points are the plus and minus output of the rectifier. Now, if our problem was on the positive side, and if I measure between the sort of AC point of the rectifier and the positive side, that's reading a short. So both AC points to the positive outputs are short, and to the DC, the negative point, that's reading just fine. So either half of that rectifier's gone, or we've got a problem with the windings. So let's just disconnect the AC points of that rectifier, and we'll see what we find there. So I disconnected the AC points of the rectifier there, and I was hoping that I would get isolation from the pad on the board so that I could make a measurement, but that didn't work very well. It's just too tight a joint. So I've disconnected the AC transformer points there, and what I find is that one of the diodes in the rectifier then reads OK, but the other one does not. So it looks like there's a short on that there. So I think the next thing is we're going to have to take the rectifier out completely and look at that. But it's looking very much like that's the problem. The rectifier's died on us. And when we look at how that's installed, it's actually not going to be so easy for us because it's tucked right in here. You know, so even if we desolder it, I can't get to it without sort of removing some of this other stuff. So we'll have to kind of go and spend a bit of time figure out how best to do that. Okay, so I managed to get that out. It came out no bad actually. We were able to just lift the pins through the board and slide it along here. So that was alright, it came out not too bad. I think the challenge is going to be, if this is faulty, getting the replacement back in. Anyway, let's just check this out the board then. So we expect a diode reading between the AC inputs and the positive there. Oh, interesting. Well, it's the wrong way around, of course. So a diode there, which we saw on the board, and then we've got a short. So this bridge is dead then. So before we rush off and replace that rectifier, only to find there's a secondary problem, I've powered the unit up without the rectifier, and I can hear the transformer buzzing, so that's fine. So it's obviously the transformer seems fine. So we'll just check the secondary windings, the secondary voltage on that. Make sure they're where we want to be. So I've got 32 on one side, and I've got 32 on the other side. So that's good. We're comfortable then that the transformer's in good shape, and we'll go off now and find a replacement for that rectifier and see if that lets us fire up the unit. So I replaced the bridge rectifier then and put together everything here that we'd taken apart to find that problem, and the unit now powers up just fine. Voltages are all fine, and you know, it just plays away just quite okay. However, we're obviously, you know, we need to look in general terms at what else is going on here. This is an old unit and things are going to have drifted a bit, and so what we're doing here is we're looking at the bias, and I'm just checking across the emitter resistors here, and I'm measuring 41 millivolts, and these resistors are 0.22 on each side, so that's 0.44 ohms total. And if we look at that, the current there, then that's going to be 0.041 divided by 0.44. So that's given us 93 milliamps of bias, and the service manual tells us it should be 50 milliamps. So things are just running too hot here, and you can feel it. You know, the heat sink's absolutely roasting. The unit's just sitting in standby here. And the annoying thing with these amplifiers is there's no variable resistor to adjust. It's actually fixed resistors that we have to change to adjust this. So that's a bit of a nuisance, but we'll get that sorted. So we need to be changing some resistors here in order to get down to 22 millivolts, which is going to be 50 milliamps. And I measured both channels, both are reading very high at the moment, and that's why things are so hot. So we'll whip out the existing resistors. There's two select on test resistors here to do this job. We'll whip them out and adjust the values to bring this voltage back down and see how we're looking then. So I'm taking the easy approach here, where I've just lifted the two select on test resistors here, and soldered in a variable resistor just in series with it. So I can never be worse than I was with the fixed resistors what we're doing here is adding some extra resistance to bring this bias into the right area. And you can see I'm down about 14 millivolts here, which is just a wee bit low. So we'll just tweak up the variable resistor until we get to where we want to be. And I'll let it settle, and then basically take out the resistor, measure it, and we'll put in a fixed value just to take us to that same setting. So there we are, 22 millivolts. That's where we should be. Now I'm never going to get such accuracy when we put in a fixed resistor, because I've only got discrete values, and it does talk about in the service manual, it says plus or minus 20% is fine. So that's sort of what, 5 millivolts either side. So I'll let that settle, and then I'll do the same in the other channel. We'll change the fixed resistors and then make a final measurement. Right, so I put in some fixed resistor values based on what we measured with the variable there, and this is us. Unit's been sitting for a wee while. I'm just measuring the bias here again, and we're sitting about 20 millivolts there. So it's a wee bit under what the ideal number from the service manual is, but actually, you know, 50 milliamps of bias is quite high, so I'm kind of happy to let this sit in the low side. And it did say plus or minus 20%, so we're well within that. And when I feel the heatsink now, there's just a gentle warmth there, as opposed to something that was obviously hot before, you know. So quite happy that that's in a much better place. So we're in good shape now. I think the only thing left I'm going to do is I'll go and check for the usual dry electrolytics and change anything that's needed, and then just put the covers on again. So this is the second unit, and we mentioned earlier that this one had some burning inside, and you can see very clearly here we've got some resistors and transistors that they've blown quite dramatically here, and it's the same on the other side of the power transistor there. There's another couple of transistors and resistors that have totally destroyed themselves. So this is an interesting situation. But the curious thing here is that this amplifier actually functions, at least. And so how's this possible? You know, when you see so many burnt parts like this, how is it possible that we actually get some output from this amplifier? But we'll explain that. First of all, let's just connect it up, and we'll look at the output signal, and then we'll talk about why this unit still works, even given the sort of severity of the destruction inside here. So we're hooked up to the scope here, and I've got a test signal coming in, and I turn up the volume. I've got quite a happy signal there, and both channels are showing the same result. So the amplifier's functioning as an amplifier, but as we said earlier, how is this possible when we've got so many burnt parts on that board? Now the good thing is that there are service manuals for these online, so we can take a look at the circuitry without sort of getting too much of a headache trying to reverse engineer the thing. So let's take a look at the schematic, and we'll look at these burnt parts and explain why the amplifier is still working, even though we've got such issues going on inside here. So here's the circuitry that's gone wrong then. This is an extract from the service manual, and what we find is that it's actually the current limit circuitry that's gone wrong. It's not anything to do with the amplifier circuitry, and that's why the unit still operates. That's why we can still see sensible signals coming through the amplifier, because the amplifier itself is quite happy, and it's just this sort of peripheral circuitry that's gone wrong in this case. And the items in the red boxes, these are the ones that have failed on us. And you know what the mechanism is, we're never really going to know what's happened there. It may just be a case that one of these devices has failed, and then one thing leads to another and takes out the rest of the circuitry. It's not an isolated case though, because I have seen this happen before. So there's maybe something that's not quite right there, that this just happens every now and again. So what does this circuitry actually do then? So we've got our power transistors, and then the emitters of the power transistors are connected through these two low value resistors to the loudspeaker. And what we're doing here is we're essentially sensing a voltage across that resistor there, and if that goes above a level enough to turn this transistor on, then it goes through the rest of the circuitry, and we end up with a logic level on this diode here that then goes on to other circuitry, and that will shut down the amplifier. So that's the basic operation. We've got a kind of symmetrical arrangement here, and we're just sensing the voltage across that resistor, and of course that'll tell us if we're pulling too much current, and we can shut things down. So that's what's going on. That's what's gone wrong, and so I've been in there and replaced all of these parts, and we can take a quick look at, and these are the parts I took out, and you can see, the transistors, they've not just failed, they've gone in good style. So it's quite amusing to see that this, as I say, circuitry is they're meant to protect the amplifier, and in this case that's actually what's failed. So let's take a look at the completed unit and see what we're going to do next. So here's the unit, and we've replaced, you can see the two sort of bluish resistors on the bottom of the picture there, as well as these two transistors, and the board's obviously kind of charred there, but that, it doesn't make any, that's not going to affect things really. That's just cosmetic. If you look at the other side as well, there was a good deal of burning here as well. So these two resistors, and we've replaced the diodes in there also. So that's where we are. So everything's back to where it should be now. We'll just take a quick look at the other side of the board here, because it's obviously, when a board is charred like this and burnt, then it's not just a case of replacing parts. You kind of have to repair burnt traces and things like that. So let's just take a look at the other side of the board. So here's the other side here, and you can see where we've put in the new parts and had to sort of do wire mods to connect them all together. It's obviously, it's not very pretty, but you do get a functioning unit where there's really very little alternative. It's either scrap the unit or you kind of do a mod like this, and it's perfectly robust. It's just maybe not the best looking thing in the world. So we're down to the last few jobs with these amps then, and the sort of big one that's left is to replace all of these connectors on the rear. You can see how damaged they are, completely useless. So these have all got to be replaced, and I've just got a bag of new connectors turned up. So we'll remove this sort of outer chassis here and remove these connectors, and then we'll set about replacing these with the new ones. Here's our new connectors all installed then, and looking very fresh there. And if you compare with what we took out, this is the sort of destruction pile, and you can see they've really disintegrated. So that's been the core of the problem there, and they really no choice but to replace these. One last job then, and that's where we saw in the beginning that we had a couple of missing buttons from these amps, and where can you get replacements? Really, you're looking at a donor unit is the only source of an original replacement. And I looked at the possibility of doing some silicon molds of these things and then trying to cast replacements, but the setup cost of that just didn't make sense for these amps. So what I ended up doing is I used some of this I think they call it poster board type material. It's labelled here as a foamed PVC sheet, and I just cut out sections of this and stacked them up, and this is what I've created. Here's two replacement knobs here, or two buttons rather, And side by side, looking face on, I don't think we can tell the difference. If I look at them side on, yeah, they're not brilliant. But for these amps, I think that's a good enough compromise. And you know, if in the future we get some replacements, then we can change them over. But for now, I'm going to go and drill some holes in the back of these, and then we'll mount them to the amps, and then that should be us done. Here's our trio of Audiolabs then, all complete. Everything's done, all 3 units. So they've all been repaired, capacitor changes, connector changes, bias adjusted, and everything's working fine in all 3 units now, which is good, because I thought we were going to have to use one as a donor unit. So that's all good. So let's just turn up the volume now and we'll have a wee listen.
Mañana tan bonita mañana.